Okay, when you're solving specific heat problems, the formula you're going to use is Q equals mc delta T. Q is always in joules, that is heat. This is the mass, which is in grams. C is the specific heat, and this is the change in temperature, which is from the previous slide. I'll show you all of this, okay? So let's look at what we've got. You've got 95 grams. All right, so what I like to do is just sub in what I know. So I've got a mass of 95.4 grams. It is increased from 25 to 48 degrees Celsius.
From, not divided. Come from, not divided. Come from, not.
Hey, we're the baker. Please leave a message.
So the change in temperature is 23. And you don't know C, the specific heat, but you know Q, which is 849. So you're going to solve this like a normal algebra problem. Multiply these, so 95.4 times 23, which gives you 2,994.2, and then you divide that so that you isolate your variable. So 849 divided by 2194.2, and you get 0.38, which will round to 0.39. And that would be in, because C, this is in joules, grams, and this is Celsius. So this would be joules per gram Celsius. Okay? All right, let's do another one. So once again, I always write down my formula. MC delta T. I know J is Q, okay, because I said Q is in the units of J. So I've got 435 joules. All right. I've got a 3.4 gram sample, so that is my mass. It is heated from 21 to 85. So 85 minus 21, that's how I get my change in temperature. It's the final minus the initial. Don't worry if it says that it's cooled and you get a negative, don't ever use the negative. Just look at the change in temperature. All right, so my change in temperature is 64, and I'm still looking for C. So multiply these and then divide it into that. So 3.4 times 64, this is 217.6. So I'm going to divide that by 217.6. And I'm going to get 1.999 or 2 joules per gram Celsius. Okay, it's really important that you write your units. Okay, let's do another one. I think this one's going to give me a different formula. Okay, so this is asking for how much heat. So I know my mass. I'm still using the formula. Okay, so I know my mass is 250 grams. I know that they raised the temperature to 52 degrees, so that is my temperature change. And I know that the specific heat of mercury is 0.14. So if I take 250 times 52 times 0.14, I'm going to get 820 joules. Okay, so when you're looking for Q, you just multiply all your numbers. All right, let's do another one. Once again, this is how much heat is required to raise the temperature of a 400 gram. So 400 gram of silver, 45 degrees. All right, so I know that I've got a temperature change of 45 degrees, and that I know my specific heat is 0.240. Okay, so 400 times 45 times 0.240. This is going to give me 4,320 joules. Okay. All right. Oops, this is a different one. All right. So I'm trying to see if I can find one that might be a little different. Well, I'll go ahead and do this one. It says how many joules of heat are needed to raise the temperature of 15 grams So you've got your mass, 15 grams. You've got a temperature change of 50 right there. And you've got a specific heat of 0.9. So when you put that all in the calculator, times 50 times 0.9, you're going to get 665 grams. Okay? So that's how you work specific heat problems. Sometimes it may ask you, when you're looking at this equation, sometimes it may ask you for the mass. It may ask you for the amount of heat, specific heat, or change in temperature. One that's a little bit tougher is when they ask you for like the final temperature. So you have to kind of set up an equation for that one. But typically these are the ones that we tend to work.